Hello grade 12s, welcome to our first video lesson. I hope that you've had a restful holiday and that you're ready to start with basically what would be our last term for content. Okay, so by the time we get to our mid-year exams, we will be done with the entire syllabus. Okay, so I hope that you're prepared to work hard and you are going to go through all the video lessons that we're going to do for the next 2 weeks. Okay, it's important for you to take note that these video lessons are 100% interactive, which means that you are required to take down the notes, to go back if you need to and rewatch some of the things, some of the explanations, to pause the video when before a question is answered so that you can answer it yourself, and then unpause the video so that you can see where it is that you went wrong or right or whatever the case may be. Okay, so for our first lesson, we're going to focus on naming esters, but before we get to that, I just want to go over some of the naming rules that we did last term. So just like a little summary. So I've made a landscape page where I've done a summary of naming rules, and then of those summaries I've made 3 columns, one for homologous series, one for functional group, and one for the suffix that will belong to that. And then I've made a 4th column which is slightly bigger just for the general naming rules that we'll go over, like ordering and the substituents and so on. Okay, so you can copy this down, so pause, copy down the columns, and then we can start. So the homologous series that we've discussed so far, the first one are the hydrocarbons. Now there are 2 hydrocarbons. The first one, which forms part of the homologous series, are the alkanes. So now alkanes are saturated hydrocarbons. Okay, so I'm going to put you in brackets just as an additional note. They are saturated hydrocarbons. Okay, that just describes what they are. Okay, the functional group for an alkane is just a carbon with 4 bonds that are surrounding it, and these bonds are all single bonds. Okay, so that's an important concept to note here. And the suffix for alkanes is ending in ane, like alkane. Okay, then something that we didn't really discuss last term, but I'm going to put it here in the summary notes as well, is that there are general formulas for the homologous series. So the general formula for a alkane is going to be CnH2n plus 2. So n is just an integer number representing the number of carbons. So if you had 2 carbons, so for example, if you had 2 carbons, you would say C2H, and then it would be 2 times 2, which is 4, plus 2 is 6. So that would be a typical, that would be the molecular formula for ethane, okay, with 2 carbons, 6 hydrogens. So it's just a way for you to see it, and it's also something that you have to know as well. Okay, so that's the first type, is the alkanes. So I'm just going to move it up just slightly, just so that there's a little bit more space, and then we will continue. Okay, then the second thing that we looked at are the second type of hydrocarbons, which are the alkenes. So the alkenes are unsaturated hydrocarbons. Okay, so they are unsaturated because they contain double bonds. Okay, so these are unsaturated hydrocarbons. Okay, and they have a general formula of CnH2n. The functional group is a double bond between the carbons, and the suffix that it will end in is going to be ene, like alkene. Okay, then the next one that we looked at were the haloalkanes. Okay, these are also referred to as alkyl halides. So a haloalkane, we don't really look at a general formula for this, but we do understand that the functional group is C bonded with an X, where X is a halogen. Okay, and that halogen can be chlorine, bromine, fluorine, or iodine. Okay, so the suffixes, we normally name it, it will be fluoro, and then it will end in ane. You can have chloro, bromo, and iodo. And it all ends in ane because they are alkanes, technically, with one of the hydrogens replaced with a halogen. Okay, then the next one we looked at were the alcohols. So with alcohols, they essentially have a hydroxyl group, which is essentially a OH that is bonded in with one of the carbons as part of the functional group. So the general formula for an alcohol is similar to that of the alkenes. So it's CnH2n plus 2 with an O at the end. Okay, so these ones will have the suffix OL. Okay, so the last one then that we looked at just before term ended were the carboxylic acids. The carboxylic acids are organic molecules that contain a carboxyl group, which is essentially a double bond O, single bond OH. Okay, the general formula for a carboxylic acid is CnH2nO2. Okay, and carboxylic acids will always end in the words oic and then acid. Okay, like butanoic acid. Okay, so those are the different types of functional groups that we discussed last term, and we practiced all the naming. So it's important for you to go over all the naming rules and everything that we did up until this point. Okay, now when we look at the general rules for naming. Okay, there are lots of general rules that we need to remember. The first rule is to remember that you need to find the longest carbon chain which includes the carbon bonded to the functional group. Okay, so for example, you can't do a longest carbon chain if you're not going to include the double bond or the carbon that's bonded to the halogen or whatever it is, you must make sure that you find the longest carbon chain, and it must include the functional group. Okay, so obviously I'm not going to write it here, but there are the number of carbons that are associated to the root name, like 1 is for meth, and 2 is eth, and 3 is prop, but, pent, hex, hept, and oct. Okay, so that's just something that you will have to go over. And then obviously then there's also the substituents. So when it comes to the substituents are always named before the root name. The root name is the name of the longest carbon chain. Okay, so substituents can either be alkyl substituents or a halogen. Okay, there are all three substituents. So you get alkyl substituents. So an alkyl substituent is like a methyl group and an ethyl group, where the methyl is for a single CH3 side chain, and an ethyl would be a CH2CH3 side chain. Okay, then the other substituent is the halogen. Okay, so also another important thing that we discussed last term is that the priority substituent is the one that you will find that will give you the smallest number in your rules of numbering. So your substituents don't take preference over one another. Okay, so the priority of substituents, let me just add here, is the one closest to the terminating carbon, which is obviously the carbon that we start with, and they have no preference except alphabetical. So, for example, you would name bromo before chloro, and so on. Okay, then it's important to remember that you need to include prefixes when there is more than one type of functional group. One group. So an example is like if there's two double bonds, then you would say diene. Or if there is three methyl groups, you would say trimethyl. Or you would say dibromo if there was two bromines. Or diol if there is two hydroxyl groups in an alcohol. Okay, then there are some other rules, like when we said for euphonic purposes, if you go look at your SANX document, we said how if you have butane 1-ol, we would say butan, an, just an, and if it was butane diol, we would say butane with a E at the end. Okay, so just make sure you review all of the detailed notes of each one that we did. Okay, but otherwise then you can write the date is the 6th of May 2025, and we are looking at the rules for naming esters. Okay, so when it comes to esters, esters is a type of reaction essentially. So when we do types of reactions, you'll see that esterification is a type of reaction that occurs when we are forming an ester. Okay, so firstly, I'm going to write that forms through an organic reaction between an alcohol with a carboxylic acid. So essentially, an ester is a combination of an alcohol and a carboxylic acid. So the functional group for a ester is a double bond oxygen, single bond oxygen, and a continued carbon chain on either side. Okay, so when we are naming an ester now, there are three parts to naming an ester. So naming an ester. Okay, the first part of naming the ester is that we always name the alcohol first. So the first part is the alcohol that we name. So when it comes to the alcohol, we name it by replacing the name and ending it in, we essentially turn the alcohol into an alkyl group. So what that means is we would take, for example, butanol. We would take out the anol part, and we would then call it butyl. Okay, so let me just fix this because it's glitching out a little bit. Butanol, and we'll take out the anol part and we'll call it now butyl. Okay, that's the first part. The second part of the name would come from the carboxylic acid. So the carboxylic acid becomes the root name. So let me also put a note here that the alcohol will form the alkyl group. The carboxylic acid forms the root name of the ester. So for example, if we had something like propanoic acid, we would get rid of the oic acid part and we would have the word propan and then end it off. In the last part which is the suffix. So the suffix for all carboxylic acids must end in the words O8. So it comes from this idea that the oic part changes to O8. So for example, I'll look at the propanoic acid again. It would change to propanoate. Okay, those are the three ways that we name an ester. Okay, so let's have a look at an example. So you're given the following functional group. We'll use butanol and we will use the propanoic acid. So we'll see it says C, 4 C's, and then we'll have the O like that. So the first thing that you would have to do here is you would have to, of course, identify the functional group first. So if you identify the functional group, you see that there's a double bond and a single bond oxygen only that's within the middle of this molecule. So that is what we need to first recognize. So by identifying the functional group, then we pick up that, okay, this is going to be an ester. So in order to name the ester, we need to start with the alcohol. Now, the alcohol comes from the hydroxyl group. So the hydroxyl group is the OH. Remember, the carboxylic acid is the double bond, single bond OH. So the single bond oxygen is here, which means that the alcohol is the part of the chain that is bonded to the single bond oxygen there. Okay, so that forms the alcohol. Then the side with that's attached to the double bond oxygen forms the carboxylic acid side. Okay, so when we number it and we're going to name it, we're going to obviously number closer to the functional group. So in this case, and we're not really too worried. You won't get any like side chains or anything like that with the esters. But if we notice that we have the longest carbon chain for the alcohol is 4 carbons, which would make it butanol. And the carboxylic acid here, now don't forget, and it's actually quite important that you don't forget this, that this carbon here is a part of this carboxylic acid group. Okay, so don't forget about that. Make a note of that, that you must still include this carbon in the carboxylic acid part. So the carboxylic acid has 3 carbons. Okay, remember, you can't ignore that carbon that's attached to the functional group. So because it's 3 carbons, that would be propanoic acid. So I want you to pause and try and see if you can get the name of this using the 3 rules that we spoke about above, now that you know what the alcohol is and the carboxylic acid is. Okay, so if we were naming it, we would start with the alcohol and we would say, well, therefore if it's butanol, we would start with butyl and then space. Propanoic acid would change to propanoate, and that's the name, butyl propanoate. Okay, so let's have a look at exercise 39. So some of the questions you would have already completed last term, but we're going to go over them now. So the first one asks you to give the IUPAC name for A, B, C, D, E, F, G, and H. So all of the structural formulas. Okay, so let's start with the first one. The first one, we identify that there's the functional group. So we can see that with this one, it's going to be a carboxylic acid. Okay, so we can see, okay, the carboxylic acid, the longest carbon chain is 4, which makes the first one butanoic acid. Okay, then if we look at B, B's functional group is also a carboxylic acid. We can see that the longest carbon chain is 2, which would make that ethanoic acid. Okay, then if we look at C, we notice that the functional group is here. So we see that this one is going to be an ester. So the first thing we're going to do is we're going to find the alcohol part. So the alcohol part is the part that's attached to the single bond oxygen. And I can see that I have 1, 2, 3, 4, 5. Okay, so that's going to start then with pentyl. Then the part that's attached to the double bond is on the right hand side. That is going to be the carboxylic acid side. So because there is 2, it would be ethanoic acid, but because it's an ester, we would end it in ethanoate. Okay, then D, I notice that I have a double bond oxygen, single bond OH. So that I know is going to be a carboxylic acid. So I can see the longest carbon chain is going to be 6. Now, if we think about where we're going to number from, even though if we do 1, 2, 3, 4, 5, 6 going that way, or 1, 2, 3, 4, 5, 6. So even though going this way gives the higher number to the substituent, we always number closest to the functional group. Remember that takes priority always. So it's going to be 1, 2, 3, 4, 5, 6. So this methyl that's attached here is going to be on carbon 4, and we always name the substituent first. So we will start by saying 4 dash methyl, and now because there is 6 carbons in the longest chain, it will be hexanoic acid. Okay. Now E, I notice again that the functional group is a carboxylic acid. So I'm going to find the longest carbon chain. So I can see here, you count 1, 2, 3, 4, 5, 6, 7. Make sure that this carbon is in the longest carbon chain. So you can only go this way, which is going to be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. So choose the longest carbon chain, which is 8. Okay, now again, you don't worry about the order of your substituents. You always number closest to this carbon here, to the side chain. So you have 1, 2, 3, 4, 5, 6, 7, 8. Now, you're going to start with the ethyl before the methyl because of alphabetical order. So the ethyl is here, the double carbon, and the methyl group is there for the single carbon on 6. So it'll be 3 ethyl, 6 methyl, octanoic acid. Okay, so you will have 3 dash ethyl dash 6 dash methyl octanoic acid. Okay, then if we look at F has a double bond and single bond oxygen, so in the middle. So we can see that with this particular one, it is going to be an ester. Okay, don't get confused. If there was a hydrogen after the oxygen, then it's a carboxylic acid, the single bond oxygen. Here I see the single bond oxygen has a carbon attached to it, so it must be an ester. Okay, so always remember, if there's 2 carbons between that oxygen, then it's an ester. So let's see, the alcohol is the carbon that is on the side next to the single bond, which is 1. So then that's going to be methanol, which changes to methyl. And then if I look at the other one, I see that the carboxylic acid only has 1 carbon, which would be methanoic acid, but because it's an ester, it would end in methanoate. Okay, G, I can see again, it's going to be a ester. Okay, there's the functional group there. So I'm going to start with the alcohol. Please take note that the alcohol will not necessarily always be on the left-hand side. Okay, you must look at the one that is next to the single bond oxygen that way. Okay, not the double bond, the single bond. So I can see this would be F for 2. So ethanol will change to ethyl. And then if I look at the next one, it will have 4 carbons attached to the carboxylic side, which is going to be butanoic acid. So in this case, it would change to butanoate. Okay, then the last one, I can see it's an carboxylic acid. The longest carbon chain is going to be 5 carbons, which would make it pentanoic acid. Okay, then number 2 says give the structure for the following compounds I, J, K, and L. So I is ethyl methanoate, so that I can see is an ester. I start with the ethyl group, which is 2 carbons. So we start there. 1 carbon, 2 carbons. Then it's the functional group for the ester, which is O bonded to a single bond carbon and then a double bond oxygen. And then it says methanoate, so that must mean that there's only 1 carbon, which is that carbon there. So I just end it in H, and then I complete my H's. Okay, J, I can see is methanoic acid, so that's a carboxylic acid with 1 carbon because of the meth. So I'm just going to have a single bond oxygen, double bond oxygen H, and then don't forget the last H on the right hand side to complete that octet rule. Okay, then K, I've put a little mark here because I was looking at it. I don't think that this one will fit very well. So it's 3 ethyl 2,6 dimethyl heptanoic acid. Okay, so I'm going to copy this, the name, just so that I can see it here when I do it separately. Okay, remember you should be answering this on separate paper anyway. Okay, so let's have a look. Always start with the functional group, right? It's a noic acid, which means it's a carboxylic acid, and it's a heptanoic acid. So this is where you should start, is by saying, okay, well, there must be 7 carbons in the longest carbon chain, so let's start with that. 1, 2, 3, 4, 5, 6, 7, and then it should end in OH. Okay, it doesn't matter which side you put your functional group as long as it's on the terminating carbon. So now we always number closest to the functional group. So I'm going to put my little numbers here: 1, 2, 3, 4, 5, 6, 7. Now this one says it's 3 ethyl group. So on the third one there will be an ethyl, and on the second one there is a methyl, and on the 6th one there is also a methyl. Okay, and then make sure you fill in all the necessary hydrogens. Okay, and then when you're done, just double check that your name makes sense, okay, because there's quite a few marks allocated to this, and it's not too difficult, I don't think. So make sure that you haven't made any silly mistakes, because one small mistake will cost you the mark for this. Okay, and remember, like I said, it doesn't matter if your group goes down the chain or up the chain, it's still exactly the same. Okay, it's just about the numbers. Okay, then for L is ethyl ethanoate. So I can see it's going to be an ester with an ethanol group and an ethanoic acid group. So I'm going to have ethanol, so it will be 2 carbons bonded to the single oxygen. Then there's the functional group, and then because it's ethanoate, I'll have 2 carbons next to the oxygen, and then finish off with my hydrogens. Okay, then the last question in this exercise, number 4, says give the structural formula and the IUPAC name of the ester which can be prepared from propanoic acid and ethanol. So it says, so the structural formula is going to be, let's quickly check. So when you do this, do it in pencil first, because then you might have to change some things, and then from there you can do the final answer in pen. So I know that ethanol is going to have 2 carbons, and then the propanoic acid is 3 carbons, 1, 2, 3, and then on that one where it's connected you'll have your double bond. So then you'll have your H groups to fill in the rest. Okay, then double check, make sure it's right, and then the IUPAC name is going to be ethanol will become ethyl, and then propanoic acid will become propanoate. Make sure that you leave a space between these two. Okay, so that's it. That's how you name esters. So for your homework, I'm going to give you part of the exam question on page 300. So it's question number 2 from the structure structured questions. So it's question 2, then question 6, the whole of 6, and question 7. And then I think that's it. Okay, so I'm going to take it down here as well, so you know it's question 2, question 6, and question 7. Okay, but also double check your Google Classroom, because the homework is also on there as well. Okay, very important. I'll put it on the Google Classroom announcements as well. But please make sure, I'm going to release a task for you on Wednesday. So Wednesday the 7th of May. And that task is going to be based on the multiple choice questions that are at the end of this unit 1. Okay, so it'll be it'll be like our normal multiple choice questions, but what I would like to see is I would like to see that you are engaging. So you'll see that on Wednesday morning at 7 o'clock, I will release the Google form, and the Google form then will have all the questions, and then you'll just choose A, B, C, or D like normal, and then at the end you'll submit it, and then I'll have a look at the results and then release the results to you. Okay, so it will be released tomorrow at 7, and then you must please make sure that it's done before Friday night. So I've set the due date to Friday the 9th of May at 23:59. So please make sure that you do it. Okay, but otherwise then I hope that you found the video lesson helpful, and that you've engaged, and that you're understanding. And then also please make sure that if you have any questions, you can just pop me an email. Otherwise, if it's very urgent and you can't get hold of me, then you're more than welcome to also ask Miss Galliani. Okay. Otherwise, then enjoy your week, and I will see you on the next one. Bye bye.